Let's solve homework exercise number 25 from section 10.2. How long must a wire be to reach the top of a 13-meter telephone pole to a point on the ground 10 meters from the base? All right, so we have our telephone pole into the ground. Here's our ground. And the top of the 13-meter telephone pole, so right at the top, is a wire, and the wire goes to the ground, of course, and it's 10 meters from the base. So this length right here would be 10. We'll assume the telephone pole is put in perpendicular to the ground, so it forms a right angle. We need to find the length of the wire. This is our wire right here. So again, we'll use X to represent the wire. Notice we have a right triangle. The 10 is one of the legs, and the 13 form the right angle. So the 10 and the 13 are the two legs, and the length of the wire is opposite the right angle, so it's the hypotenuse. So again, the Pythagorean theorem, c squared equals a squared plus b squared. C is the hypotenuse, so I called it X. You can leave it C if you want. X squared, or maybe what I should do is just say the length is C to stand for the hypotenuse. Doesn't really matter. C squared is equal to 13 squared plus 10 squared. I know 13 times 13 is 169. 10 squared is 100. So C squared equals 169 plus 100. Add those two together and we get 269. Take the square root of both sides, and C is equal to the square root of 269. I don't think that's a perfect square, so we're going to go second x squared, get the radical, put in 269, and then round to the nearest thousandth. Thousandth is 3 decimal places, okay? Thousandths is 3 decimal places. Okay, so we'll go ahead and put in the square root of 269 on our calculator. Go ahead and calculate that. So we have second x squared, the radical of the square root of 269. Okay, 3 decimal places, remember, to the nearest thousand. So we have 16.4012. The fourth decimal is a 2, so we don't add anything to the 1. We round down, so it would be 16.401, and everything is in meters. So 16.401 meters is the length of the pole, or the wire. Sorry, the length of the wire. The pole was given to be 13, all right, 16.401. Yeah, the length of the wire, the hypotenuse. Very good. Let's look at problem number 26. Okay, how tall is the tree? And again, they give us a picture. All right, and we have 13. Here's the tree right here. Can't draw a tree very well, right? But anyway, we need to find the height of the tree. The shadow, the sun's coming down here. The length of this is 44, and the shadow along the ground is 13, so it's really not drawn proportionally correct. But you go by the length. So anyway, we'll assume that the tree and the ground forms the right angle. So the tree, and boy, that's a pretty sloppy tree, isn't it? All right, maybe I should have just did a tree like that. But anyway, the height of the tree and the ground form the right angle, right? There's the right angle there. So those two are the two sides, legs, and 44 is opposite the right angle. So that's the hypotenuse. Okay, so again, we're going to have c squared equals a squared by the Pythagorean theorem. The hypotenuse is 44 squared is equal to 13 squared plus, I called this height. Again, it doesn't matter what you use for your variable, a, b, h for height. Okay, all right, anyway, I know 13 squared is 169. But 44 squared, I don't know what that is, so I'll go ahead and do that on the calculator. So 44 squared is 1936. So again, by the Pythagorean theorem, we had what? 44, the hypotenuse squared, is equal to h squared plus 13 squared. 44 squared is 1,936 equals h squared plus 169. Subtract 169 from both sides, and you get, do the math in our head. I mean, do it pencil and paper, not in my head. 12, 6, 7, 1,767 is equal to h squared. So then h squared equals 1,767. Take the square root of both sides. Get h is the square root of 1,767, and that will give us the height of the tree. Okay? So again, second x squared will give us the radical, and then we can put in 1,767. 1,767, the square root, to get the height of the tree. All right, so using our calculator, second x squared, 1,767. All right. And again, round answer to the nearest thousandth, 3 decimal places. So we have 42.0356. A 6 is in the 4th decimal, so we're going to add 1, round up. So 42.036. And that would be obviously in feet, because everything else is in feet. Oh, they already give the units, okay? So we're going to go ahead and put that in, 42.036. All right, very good. Number 27. An airplane is flying in an altitude of 4,198 feet. The slanted distance directly to the airport is 5,556 feet. How far is the airplane horizontally from the airport? So horizontally is right there. So there is your right triangle, correct? Horizontally and vertically forms a right angle. 4,198. This is 5,560, and the horizontal is labeled A. So again, right triangle can apply the Pythagorean theorem. C squared equals A squared plus B squared. The opposite the right angle, you can see the right angle, the legs are 4198 in A. Opposite the right angle is 5,056. So 5,056 squared is equal to the A squared horizontal plus vertical, 4,198 squared. Okay, so we're going to go ahead and do those two numbers, square them on our calculator. 5,056 5,056 squared. Oops, I didn't square it. 5,056 squared. Okay, and 4,198 squared. And then when we're going to have to find the difference, so I'll go ahead and do that already when we're solving. 255,631 36 minus 176,232,04. And the difference is going to be that right there. Okay, so again, you'll see why I did the difference. So again, the Pythagorean theorem, 56 squared is equal to A squared plus 4198 squared. And then we got 56 squared was 255,631,36, which is actually about 25 million equals A squared plus 4198 squared was 176,232.04, which was actually 17 million. So then we're going to subtract the 17 million from both sides. 176,232.04 subtracted from both sides. And then I already did it on the calculator there, and we got 77,939,932 is equal to a squared. So then we're going to take the square root of both sides, and we're going to round to 3 decimal places. So that last number, I already did the subtraction on the calculator. We're going to go ahead and take that number, 7,939,932. Oh, okay, sorry. We're going to take the square root of that, right? So we're going to go ahead and do second square root 7,939,932, and we're going to get to the nearest tenth 7.884. So we're going to keep the 8 and 8. The 4 is 5 or less. So the answer is going to be 2,817.884. Okay? 2,007,9399. Okay. Whoa, whoa, whoa. Sorry. 0.788. Sorry. Let's look at that number. 2,817 point. Put in the wrong number. 788. I was concentrating on the 4. There it is. Good job. I thought we did it correctly. Okay, so very good. Again, apply the Pythagorean theorem. We're going to stop this session here. If you have any questions, send me an email at tsquares@hodges.edu or call me at 239-938-7805. Thank you.